Welcome to College Algebra. In this lecture video, we are going to continue to talk about our polynomial functions. Let us put the leading term test and even and odd multiplicity into good practice here. So this is the part 2 of our lecture video 4.1. So the first question I have on the handout says plot the X intercept, if any, of the polynomial function on the graph. So what I'm going to do is basically kind of like doing both of these steps together. So I got to plot the X intercept, and I am very aware we can simply just put this function in the graphing calculator. It will plot it for me because I can find my X intercept from the table. But since we are talking about the even and odd function, I would like to show you how to do this problem using those concepts. Alright, X intercept. Find X when Y is equal to 0. So I'm going to try to factor this thing, because one of the very first way to find 0 over X intercept is by factoring. So let's see. This is a quadratic equation. So let's factor 1 and 5. The last sign is negative, so my signs would be 1 positive, 1 negative. To end up with the positive 4 in the middle, I need positive 5 on the outer, negative 1 in the inner. Alright, set each factor equal to 0. One of my X is equal to 1, and the other one, X equal to negative 5. So when I enter in as X intercept, or if I just click on it, okay, remember X intercepts are coordinates. So we will say negative 5 comma 0, and the other one will be positive 1 comma 0. Alright, those are my two coordinates. And I'm going to go ahead and plot them too. One, 0 right here, and negative 5, 0. Now I know that this is a parabola. This is going to be a U open up because it's a positive coefficient. So thinking about in terms of even and odd function, the factors, the exponent of my factor are both 1. So I know that my graph will cross over at both of these X intercepts. Okay, degree is even, positive leading coefficient, so that will be scribble, scribble, scribble. Right side goes up, left side goes up too. So naturally, when we sketch this thing, this side gotta be above it, that side gotta be above it, and I'm not doing this exactly accurate. I'm just kind of sketching it. Alright, so as I'm coming from negative infinity for my X value, once I reach negative 5, I will cross it over, and then I will eventually turn and then go towards my, oh Lord, with the crooked, sorry. I'll eventually turn, maybe a little bit down, I'm just sketching it, and I'll eventually turn and go towards the other X intercept. And once I get there, I will cross it because I'm forced. Okay, if I know the ending behavior, both of these sides will go up and up. Once I actually coming in from negative infinity for X, once I go down here, I got to eventually curve back up and actually cross over at the other X intercept, and for me to continue to go up. So I'm sketching this not very accurately because I'm not doing the vertex of my parabola. I'm not doing the y-intercept of my parabola as well. So if I could find another 2 points, that will make my graph a lot better, look a lot better. And I can also do, since this is an even function, since this parabola is an even function, I could actually find other coordinates to help me to sketch. So I kind of want to show you how we can graph this just by thinking about the leading term test and even the odd function. Now when the problem says identifying where the graph is positive. That positive right here is referring to the y value. Where are the y value positive, negative? So our reference are the two x-intercept. So to the left side of this x-intercept, the y value is positive on the top, above the x-axis. Between the two x-intercept, my y value is negative, so that's below the x-axis. So that's what you click on. So once you reach the other x-intercept, then you gotta cross over it, so we will click positive again for the y value, which you would just click on above the x-axis. Alright, let's try another one. This is a cubic function. So if I remember correctly, is what? Right side goes up, left side goes down. It will look something like this. So if not, you can always refer back to these pictures. Okay. Alright, so I have an overall idea of what the picture may look like. So let's plot some of the x-intercepts. Alright, the degree of the polynomial is 3. That tells me that I will have at most 3 x-intercepts. Or 3 zeros. 3 0 is a better wording. Okay. Alright, set my y equal to 0. And these three terms, all of them has x, so I can factor out x, and that will give me x squared plus 5x plus 6. So in my parenthesis, that's a trinomial, so I will keep on factoring. X and x, 1 and 6, both are going to be positive. Oh, can't use that, can I? Can't use 1 and 6. I gotta use who to end up with the 5? 2 and 3. There you go. 2 times 3 is 6. In and out are gonna be positive to end up with positive 5 in the middle. So set each factor equal to 0. So this x I factor out is a factor, set equal to 0. The other one is -2. The third one, -3. So if you look at the exponent of my factor, the first thing I factor out was my x. The exponent is 1. This is 1. This is 1. So again, my graph will cross over my x-axis at these 3 coordinates, these 3 x-intercepts. Alright, let me plot these 3 points for you. So the way I'm doing this is by plotting the 3 x-intercept. 0, -2, -3. Okay, think about this, okay? If the graph's supposed to look like this, that means it goes down as x go into negative infinity, the y value goes down. So that means this side is going to be down. Alright, so now drawing this from left to right, well, excuse me, after this x-intercept, it got to be upward. So coming from negative infinity, which is coming from down here for y value, once I reach my -3 x-intercept, I got to cross over, and then I got to connect with my -2, so I got to curve back towards x equal to -2. And once I got there, what do? Cross over, and eventually I got to cross back towards the other x-intercept. Once I get there, I cross over, keep on going to infinity. So knowing the ending behavior does help a little bit when we're graphing this. So let's take a look. My x-intercept, my very left, my most left x-intercept is right here. To the left of it, my y value is actually negative. So that's the part you click. Between -2 and -3, excuse me, between -2 and -3, my y value is actually positive. So you click above. Between -2 and 0, it becomes negative again. To the right side of 0, it becomes positive again. There you go. That's what the positive negative is referring to. Alright. Now consider this particular polynomial. This one already factored for me. But if you would think x times x times x times x, it's actually going to end up to be x to the 4th power. Okay. Now, be careful now. This is a positive x times positive x times positive x times negative x. So it's actually going to be end up to be negative x to the 4 something. Okay. I'm not worried about the numerical answer of my leading coefficient. I'm just worried about the signs and the exponent on the leading term. Because now that tells me that exponent is even, but the leading coefficient will end up to be negative. So both sides point down. Okay, let me write it down here. Okay, scribble, scribble, scribble. Both ending behavior going downward. Alright, so since these this particular problem already factored for me, so I'm going to set each factor equal to 0. So my x-intercept will be negative 1, 0. The other x-intercept, negative 2, 0. Positive 1, 0. Oh Lord, it crossed over 4 times because all these exponents on the outside of the factors are odd. 2 minus x set equal to 0. If I move my negative x over to the right, x will equal to 2. Alright, so let me plot these 4 x-intercept. Negative 1, negative 2, kind of tight. 1 and 2. So again, I am very aware. You can type in all these. You can type in this function, and the graphing calculator will show you what it's doing. Okay. The reason why I'm not showing y'all that, just in case, if one of my x-intercept end up with a fraction, then I can't figure out exactly what my x-intercept is. Because if I have a fraction x-intercept, we cannot find it on the table. Alright, so thinking about this picture, look at these points. I know my two most outer x-intercept got to be down and down. Alright, so to the left of my negative 2, the y values are negative. Between negative 2 and negative 1 is positive because I got to cross it and turn back towards it. Why? Why did I cross it coming from the left? Because the multiplicity on these factors are all odd. Cross it over, cross back, curve back, cross over, and then curve back towards the rightmost and go down. So you will look something like this. Negative, positive between those two, negative y value between those two, positive y value between those two, negative y value to the right side of x equal to 2. Let me graph it. X plus 1. Something like that. Yeah, my picture is not as pretty as that one, of course. Alrighty. Alright, let's solve some of these equations by factoring or using quadratic formula. I will only use quadratic formula if I cannot do it by factoring, because quadratic formula is a little bit of work. 45. What times what is 45 if I factor this quadratic equation? I don't know. Normally it's 4 times 9. 4 and 9 together is not 12. I mean 9 times 5. Not 4 times 9. 9 times 5. These two add up together to be 14, not 12. So before 5 times 9, there's another set of factor that's equal to 45. So I know I should have 1 times 45. 2 cannot go into 45. 3 can. 3 go into 15 times. Crap. I don't think I have it. 4 cannot go into 45. Alright, so this one, not really, can't really do it by factoring. Alright, quadratic formula. A is equal to 1, B equal to negative 12, C equal to C equal to positive 45. So X equals negative B, that will be negative of my negative 12, plus minus square root of B is negative 12, whole thing squared, minus 4 times my A times my C, whole thing over 2 times my A, which is 1. Alright, let's see what that's going to come out to be. So we type in, during the review we said type in what's inside the square root. See what that turned out to be. Without the square root, of course. Well, 36 is factor of, yeah, 36, negative 36. It's negative 36. Ooh. Okay. Negative 12 is positive 12 here. Plus minus square root of negative 36 over 2. Square root of 36 is 6. Square root of negative 1 becomes my I. So that's 12 plus minus 6i over 2. When all the numbers on the outside can be reduced, we will reduce them. If I reduce all of them by 2, my answer will be 6 plus 3i or minus 3i. So technically, I do not have any x-intercept, but these two are my solution to the equation. Okay, or these two are my zeros of a function. Okay. Alright, let's try another one. See if we can do it by factoring. I'm not quite sure. 48, 6 times 8. And you know that ain't gonna work. Because 2 is 1 times 2. Doesn't matter what I put the 2. That will cost me a greatest common factor. So let's use a different numbers rather than 6 and 8. Oh, by the way, if I will graph this parabola in the graphing calculator, you will actually not see it cross over the x-axis. Okay, because this one does not have any x-intercept. Because with the I, it's not a real number anymore. Well, 48 besides 6 times 8. I can use a 4. 4 and 12. That's still not going to together equal to 35. 3 and 16 maybe? That's 19. No. 2 times 24? No, that's 26 if I add them. So this one again cannot be factored. Let me graph this one first. I notice a parabola opened up just by looking at the function itself and the leading coefficient. And plus 2 tells me that my parabola has shifted up 2 places too as well, or my y-intercept is up there. My vertex could actually be somewhere else. No, it's, yeah, vertex is about a little bit right there. Yeah, you cross over it. But if I go to my table, it looks like it cross over right around the origin. But I don't see any y equal to 0. So that's the reason why we got to find the x-intercept by hand, or the solution by hand, by using quadratic formula. A is 48. B is negative 35. C is positive 2. So my x will equal to negative b plus minus square root of my b squared minus 4 times my a, lower big numbers, times my c. Whole thing over 2 times my a, 48. Alright, let me type in what's inside the square root. And what's inside the square root tells me, you know, it basically tells me why I cannot factor. If inside the square root is a perfect square number, it will be factorable. I know the negative 36 was actually perfect square, but with a negative, it actually becomes imaginary. Be sure you put that negative 35 in the parenthesis to the second power, okay? Otherwise, you'll throw your answer off without that parenthesis. Oh, I'm sorry, my C is 2. Sorry. It's supposed to be 2 right there. Ooh, almost messed it up. There we go. 841. Ugh. So that would be 35 plus minus square root of 841. Whole thing over 2 times 48, which is 96. Alright, let's see if I can break down this 841. It's pretty nasty. So prime factorization to break it down. I know 2 cannot go into it. 3 cannot go into it. I'm thinking, the reason I'm thinking 3 is because 3 times 7 ends with a 1. So since this number is so big, you know, I need to kind of move it up a little bit using my other prime numbers. Remember, I'm using prime numbers only, okay? 3, 2, 3, 5, 7. Let me try 7. 841 divided by 7. Nope. Alright, look at that difference, okay? The difference will start shrinking when one of my number gets big. 7. 7 times 3 ends with a 1, right? 8, 9, 10, 11. 11 times 1 is ends with 11. So 841 divided by 11. Nope, that's not going evenly. See how these two numbers difference is getting smaller. 11, 13. 13 is the next one. Nope. 17. So is the next prime number. I don't think we can do it. 19. 9 times 1 ends with a 3. 19 is a prime number. 19 times 9 is 81. So that's worth a try. Nope. The next one would be 20. 19, 20, 21, 22. 23 is a prime number. $36 now. 23, 24, 25, 26, 27, 28, 29 is the next one. Bam. 29 squared. Whew, that's a lot of work. 849, 29 times 29. So that means this problem could be actually what? That tells me that this problem could actually be factor. I just didn't work hard enough to thinking about it. I sure didn't. Whew. So my answers 35 plus 29 divided by 96. 35 plus 29 divided by 96. Convert to a fraction. 2/3. minus 29 divided by 96. Convert to a fraction. 1/16. So earlier when I listed out 6 and 8 cannot be 6 and 8. 3 times 16 is 48. The 2 gotta go here. 2 times 12 is what? What's 2 times 12? Not 2 times 12. 2 times 16. 32. See, 32 plus 3 on the outer will give me 35. Yeah, could have factored it. So if I set each factor equal to 0, okay. Oh, excuse me, gotta be both negative, not positive. So 3x minus 2 set equal to 0, x equal to 2/3, and this is where the 1/16 comes from. So, you know, I just want to kind of show y'all that, hey, you know, the 841 was big number. Quadratic formula sometimes is okay, sometimes it's actually a lot more work on the problem that is factorable. Okay, if a problem is factorable and I use quadratic formula, sometimes it's a lot of work, sometimes it's not. It's really hard to tell unless you figure out what's inside the square roots. Alright, so now Mr. Chen will do a little bit better. Third power, at most 3 X intercept over 3 zeros. I'm going to factor out my x. That give me x squared minus 15 x. See all these? See those two answers? Both are fractions. Plus 36. Can't find those in the table. Yucky. 36 normally is 6 times 6. Before 6 times 6 it was what? 4 times 9. The plus sign here tell me to add it up to give me my middle term. No. 3 times what? 12, right? Isn't that 36? Yep. Which is 15. So here we go. Factorable again. X and X. 3 and 12. To end up with a negative 15, both of these gotta be negative because the last sign is positive. So my answer, set my first factor x equal to 0. Second factor set equal to 0, x equal to 3. Set my last factor equal to 0, x equal to 12. You will have these 3 x intercepts. Alright, this last one is called the quadratic inform. To be considered as a trinomial. Trinomial got to have exponent that has 210 flavor. 210 flavor. So when you see a 420, that means those 3 exponent is just twice as large, okay, as the regular one. So what that means is, if this problem is factorable, rather than having x and x, exponent twice as large, so we will use x squared and x squared. Okay, still a trinomial. It's trinomial in form or quadratic in form. 15, 3 and 5, of course. Both are gonna be negative. To end up with a negative 8. Oh, this is interesting. X squared minus 3 is equal to 0. So if I get x by itself, if I get x squared by itself, x squared equal to 3. if I take a square root on both sides, x is equal to positive and negative square root of 3. That's 2 answers right here out of the 4. And these 2 can be my x-intercept. So if I set x squared minus 5 equal to 0, move the negative 5 over, take a square root on both sides, x is equal to positive and negative square root of 5. Alright, so these 4 x-intercept or zeros cannot be found on the table. As a matter of fact, if you type in square root, you know what, randomly graphing, I'm going to do this. If I type in square root, positive square root of 3, that's an irrational number. So there's no way we could actually tell, you know, in terms of a fraction, we cannot even tell since it's an irrational number. So this problem, we'll have to do it by hand. A calculator is not going to be very useful here. So remember now, if we go back to the ways, okay, factoring is the number one way. Sometimes certain problem we can do about graphing if the x-intercept or zeros are whole numbers, okay. But however, though, there will be time where factoring cannot work. Problem that is not factorable, graphing, no x-intercept is 0. Okay, so when those 2 fails, then this third way will come in. Okay, this third way is going to be called the ultimate way to find the 0, and we will introduce that, you know, later on in chapter 4. All right, I'm going to stop this video here. Thank you for watching.